Problem 16. In this problem we have few figures that we want to place the principal stress directions on the pair of conjugate shear surfaces. Before going through it, let's see the basics. Okay, we have actually here a conjugate fault, and as you know, the conjugate fault is a set of cross-cutting faults which ideally intersects 60 degrees and 120 degrees. And the maximum principal stress, which is sigma 1, bisects acute angle. The sigma 2 is the intersection of the conjugate faults, and the sigma 3 bisects the obtuse angle. Okay, this is our rules, and let's see how we can place sigma 1, 2, and 3 on these three sketches. Okay, as I mentioned, okay, the intersection, it's gonna be sigma 2 on this figure. Okay. This is the direction of the sigma 2, and x that this x, which bisects acute angle, is sigma 1, and the other one is sigma 3. In this type of setting of sigma 1, 2, and 3, we would expect having a reverse fault. Why? Because sigma 1, okay, it's parallel to the horizon, and it will actually create kind of, it's going to create the compressional structures, including the reverse fault and thrust faults. The second one, okay, is this one. Again, let's place the sigma 2 and sigma 1 and sigma 3, right? So here the sigma 1 is perpendicular to the horizon, and what that means is we're gonna have the extensional systems. Okay, if the sigma 1 is perpendicular to horizon, we would expect the normal faults, and as you know, the normal faults normally appear to be high angle, like 60 degrees with respect to the horizon, but the reverse fault and thrust fault, they have a lower angle, and it's about 30 degrees with horizon. As you see here, if we assume this is the horizon, this angle 30 degrees, and here is this plane and this horizon, it's about 60 degrees. And the last one, okay, here the sigma 2 is perpendicular to horizon, and sigma 1 is placed like that, and here is sigma 3, and if we have this setting of the principal stress axis and sigma 2 is perpendicular to horizon, we would expect having a struck slip faults.